Welcome. We're learning Unit Circle Part 2. So let's focus on the first quadrant. Here's a unit circle. Again, it's a radius of 1. Its center is at the origin in this case because what we've done is we've taken our circle and we kind of slapped it on top of an XY plane. Again, with the center of the circle at the origin. Okay, we might want to know, what's really important would be what are the XY values on the circle. Okay, because those are it's like an address. We want to know where we are when we're moving around the circle. Now, if you start at 0, the XY value, since we're on the x-axis, this is at A, the y value is going to be 0 because you're on the x-axis. The x value is going to be 1. The reason is because the distance between C and A, in this case, is 1, the radius of our circle. So we know that value. If we travel around the circle to pi over 2, and we want to know what that xy value is, well, we're on the y-axis, so that means that the x value would be 0. And again, the y value is 1 because the distance between C and B is 1. That's our radius. And you can continue to move around the circle to pi or 3 pi over 2 and follow the same logic to find out what those xy values are. The problem lies when you're not on the axis, but somewhere in between on the circle. And as we said when I did part 1 of these videos, I talked about pi over 3, pi over 4, pi over 6. Those are the most common angles that you're going to be dealing with, okay? So we can do a lot of geometry to calculate those xy values, or we can use a process that I think works very nicely. So let's do that. If you go to F and you see here I've listed pi over 3 through pi over 6. You have to list them in this particular order for this to work, okay? Then I've listed x under x 1, 2, 3, and under y 3, 2, 1. Okay, you can do that. And then if you move to box G, all I've done is taken the square root of everything. Okay, square root of 1 is 1, so that's why there's no radical there. And then in H, I've divided everything by 2. So if you do this, I have just come up with the x and y values for pi over 3, pi over 4, and pi over 6. Now, at this point, I want to review some quick trig for you. The cosine of theta, theta is your angle, is x over r, and sine of theta is y over r being our radius. Since the radius is 1, it really means that the cosine of theta in this case is just x, and the sine of theta is y. So let's do an example. If I ask you to find the sine of pi over 3, first thing we notice, we're asking for the sine, okay? So that means I'm really asking, what's the y value at pi over 3? So how do I do that? Well, we use the chart that we created a few slides ago. So if you go to G, I've put this box back up for you, and you move down to pi over 3, what is the y value there? Well, it's square root of 3 over 2. And guess what? That's your answer. That's how you do this problem. In another example, let's just say I ask for the cosine of pi over 4. Again, cosine is the x value. Okay, so you go to your chart in F, go to pi over 4, and what's the x value? Square root of 2 over 2. And that's your answer. Now, if I want to know other trig functions, say tangent, cotangent, secant, or cosecant, no problem. So long I know both the sine and the cosine, basically the x and the y value, I can calculate any other one of these functions because they're all made up of sine and cosine. And that's Unit Circle Part 2. Now go practice, practice, and practice some more.